I'm going to turn it over to you.
Okay, well, welcome. And are we starting with the best talk? No, thank you everyone for coming. And we're so excited to have this presentation. We're also going to be recording, and we're actually also having live interpretation in Spanish because I will be sharing this talk with growers across California. And today we'll be highlighting our research project that we've done collaboratively with some of you here in the room, and then also with other stakeholders across the United States, from California, Nebraska, Florida. Of course, this is a specialty crop research initiative project that is funded by the United States Department of Food and Agriculture. And one of the things that we've observed over the years is really sort of a shift in the change in the perception of biodegradable mulch, especially here for California. And so we're excited to share with you all some of the updates on the findings, but also, again, this is just an additional tool, as Lisa always says, an additional tool for the toolbox, another option. So if we're ready, I think we're ready to get started. Kevin, are we ready? Okay. Javier, are we ready? Estamos listos. Okay, Javier says we're ready, so we're ready. I'll pass it on to Lisa. Thank you.
All right. Well, I'm Lisa Wasko, DeVetter. I am an associate professor at Washington State University, so I just don't have the dynamic poise that Jazmine has. I tend to stand here very stiffly and tell you a lot of information very rapidly, but I'll try to slow it down. But as Jazmine said, we are focusing on soil biodegradable plastic mulches, which I come from Iowa, a bit of a farming background, and working in farming systems. Having more tools available has always been really helpful for growers to make informed decisions. So hopefully by the end of today, all of our listeners will learn about how biodegradable plastics might serve a role in terms of reducing agricultural plastic waste generation, and then how it might fit within this larger ecosystem where recycling is also an option. So we're going to kick this workshop off by talking about just what is a biodegradable plastic mulch, or you'll see this abbreviated as a BDM. I want to acknowledge that we are part of a large collaborative team, and you can see the multiple public and private institutions listed on this slide. And we are funded from the United States Department of Agriculture Specialty Crop Block Grant. And we have a big focus on biodegradable plastic mulch, but we also have a focus on recycling. And you're going to hear some of those presentations from other members of our project team later on during this overall recycling conference. I also want to thank Jean for reaching out and providing us a space to talk about biodegradable plastic mulches at this venue. So let's kind of just frame why we are here. We are here because we are all seeing a problem associated with agricultural plastic waste generation. And when we talk about plastic mulches, that's really where we see a fit for soil biodegradable plastic mulches, or BDMs. So most of the mulches used in agricultural production systems or specialty crop agriculture is polyethylene mulch, or you'll see that abbreviated as PE mulch. And rarely do we see it being recycled. And a lot of that, you probably realize, is because of the high contaminant load. What happens for production systems like strawberry growers or other specialty crop growers that really benefit from polyethylene mulch is that it's landfilled, like this picture here from Rengen here in California. It's sometimes burned in certain states where that's allowed, and sometimes it's also tilled into the soil. The FAO estimated that the annual generation of agricultural plastic mulch film is 2.5 million metric tons every year. And that number is growing up because more and more producers are seeing a benefit to agricultural plastic mulch. It's just the issue is end-of-life management, and that's what brings us here together. So soil biodegradable plastic mulches are an alternative to polyethylene mulch. They provide the crop production benefits equivalent to polyethylene mulch in most experiments, and we'll talk about how long biodegradable plastic mulches have been on the market in the next few slides. But biodegradable plastic mulch provides a barrier over the soil surface, and that lends itself to weed suppression for many weed species. It also optimizes the soil microenvironment, so elevating or cooling the soil based on the color of the mulch, and then also helping with moisture retention as well by providing a barrier. And in certain production systems, it can optimize the harvest timing. So typically we're looking for earlier harvest timing with our black mulches compared to bare ground. And then it can also increase crop yield and quality. And that is a real big economic driver and incentive for growers to use biodegradable plastic mulch and polyethylene mulch. The key difference with biodegradable plastic mulch is that the intended end of life is incorporation in the soil, where the grower is meant to till that mulch into the soil, where it'll subsequently be degraded by microorganisms in the soil. And that reduces the generation of agricultural plastic waste because you no longer have that costly process of removal and then disposal at the end of its lifespan. And we are in many cases talking to growers in our extension efforts about biodegradable plastic mulches. And so we have to make it clear that the end of life of biodegradable plastic mulch is incorporation into the soil. It's not intended for recycling. And if we do put it in the recycling stream, it can contaminate the recyclate, and which is something we certainly don't want to do as we see recycling efforts gain steam. So a little bit about the history of biodegradable plastic mulches. It all started in Germany in the 1990s, where the German government published a call for research and development on biodegradable thermoplastics. And Novamont, which is a company in northern Italy, answered shortly thereafter in 1991 and produced Matter B, which is a line that goes into making a lot of biodegradable and compostable materials, mulch just being among them. And then in 1996, Bayer BAK, they introduced line extrusion and injection molding using their own type of biodegradable feedstock. And in 2009, the United States really started investigating biodegradable plastic mulches at large scales across multiple locations. And since then, there's been three government-funded projects looking at biodegradable plastic mulches and their implementation in specialty crop agriculture. The team that I presented earlier being the third one. And again, we're looking at biodegradable plastic mulches in addition to recycling, which has been a new element and twist to this line of research. And then in 2014, BASF introduced organic ag solution film. This is made with their EcoVio feedstock. Organic ag is no longer on the market, or it's really hard to find, but the EcoVio feedstock is still present. It just depends on who you're sourcing your mulch material from. Let's talk a little bit about feedstocks, because this is a question we often get, particularly as we start thinking about the intended end of life for soil incorporation. So plastic biodegradable mulches are made from feedstocks that are bio-based. They also can be derived from fossil fuels or synthetic. And typically what we see in commercial production systems, they're a blend of the two. And so bio-based polymers are then subsequently divided into three categories. The first one is extracted from natural materials. That would be starch, thermoplastic starch being the most common and most widely used because it's the most widely available of the bio-based polymers, and it's also lower in cost. Next is the bio-based polymer that is produced by chemical synthesis, PLA or polylactic acid being a common one. This is also produced relatively inexpensively and commonly found in certain types of biodegradable plastic mulches. And then the last one is produced by microorganisms, and the polyhydroxyalkanates or PHA would be an example of those. Something that's important that we also have to remember and reiterate a lot of times when we're talking about biodegradable plastic mulches, particularly with the organic community, is that the percent bio-based content is not an indicator of the biodegradation. It seems like with the National Organic Standards Board, they have this misperception that if you increase the bio-based content, we're going to have better in-soil biodegradation, but that's really not the case. And that can have that's had some consequences with regards to having these materials available for organic producers, because the National Organic Standard Boards right now has a requirement for 100% bio-based content for biodegradable mulches to be used in organic agriculture. And none of the commercially available materials meet that criterion. A little bit more on standards for biodegradation. The standards are really important because they're intended to ensure that the biodegradable mulch has the quality and integrity for application in agriculture. It's also intended to exclude certain materials that are erroneously labeled as biodegradable mulches, but do not fully break down or are mineralized by microorganisms. A good example would be some of the oxodegradables or the photodegradable mulches. Those oftentimes are sold to growers as biodegradable, but if you look at the standards, which we encourage growers to do, you'll see that they don't meet some of the standards that I'll be highlighting in a moment. Composting standards, those are the first kind of litmus test what we recommend people look at if they're evaluating a material and determining whether or not it's biodegradable. It's the first critical test of biodegradability. And if it's not compostable, then it's likely not going to degrade in the soil environment because the composting condition is a lot more suitable for biodegradation. And then the other thing that we also have to point out is agriculture is diverse. So biodegradable mulches are applied in diverse applications. So even if these materials meet the standard, it doesn't necessarily guarantee a particular degree of performance. There's a lot of other factors that affect the performance within the producer's field, such as the production system, so the crop, the climate, the soil conditions, the actual formulation and thickness of the mulch, and then also the particular farming practices at that each individual farm. So let's look a little bit more closely at the standards. This is a handful of standards. We're going to be looking closely in the next slide at the European Committee for Standardization EN 17033. That is an important one for biodegradable plastic mulches because it's the first one that pertains to in-soil biodegradation, but one that's commonly used that we'll focus on in the next slide is ASTM D6400, and that is pertaining to industrial composting conditions. So let's take a look at these. The first one, again, being ASTM D6400. This is the biodegradation test under industrial composting conditions, and it's the most commonly cited standard for biodegradable plastic mulches. And it utilizes the standardized test method, ASTM D5338. And this laboratory test is designed to simulate industrial composting conditions. So you'll see it's in a compost-based medium at temperatures about 136 degrees Fahrenheit, which is not reminiscent of what we would see in agricultural production soils, but it does require 90% conversion of the carbon in that material to carbon dioxide and microbial biomass within 180 days. The one that's more relevant for biodegradable plastic mulches that was released in 2018 is EN 17033. This is the European Committee for Standardization. And this one's important because it's the first standard for certification for biodegradable plastic mulch films in soil, not in composting conditions. And it also has requirements regulated on composition, biodegradability in soil, ecotoxicity, dimensional, mechanical, and optical properties, and it provides test procedures for each. So it's a very thorough one, and it's one that a lot of people in the biodegradable mulch community are very excited about. It requires 90% biodegradation under aerobic conditions using topsoil, either from agricultural fields or forest soils, at temperatures that are more reminiscent of what we would see in open field agricultural production. And you'll see between 68 to 82 degrees Fahrenheit. And it requires 90% biodegradation within 2 years or less, utilizing standardized methods for measuring CO2 evolution. And oftentimes we get the question, why is it 90% biodegradation and not 100%? Don't we want full biodegradation? And a lot of that is because some of the carbon in biodegradable mulch is accumulated in the biomass of the microorganisms breaking it down, which are difficult to measure. And then also it's the sensitivity of the instruments used to measure the carbon evolution or CO2 evolution. So 90% is a good baseline because we in actuality won't be able to see full or 100% biodegradation with our methodologies. So that was a crash course in what is a biodegradable plastic mulch. Again, they're a promising alternative to traditional polyethylene mulch, which is non-biodegradable, and they might provide a viable alternative to reduce persistent plastic waste generation that we see and be a good option when recycling is not an option for the producer. Our project team is doing continued research, exploring the longer-term soil health impacts, as well as understanding fate and residency time of biodegradable plastic mulches in a diversity of soils, which is a critical question that we get when we talk to producers, as well as the National Organic Standard Board that is looking to consider these material for use in organic agriculture. So with that, I want to acknowledge again the United States Department of Agriculture for funding. And if you're interested in learning more, we have a project website that is focused on mulch right now, but we're looking forward to expanding it and including recycling as time moves forward with our collaborative project. And Jazmine is my task manager and my timekeeper. Do we have time for any questions? Oh, all right. So any questions from the audience? Yeah. Oh, and I'm happy to repeat the question as well. You know,
Thank you.
Test.
Yeah. Sounds interesting. Part of me says it's might be a disaster waiting to happen. I mean, I know this stuff is being used. We've seen so many bad examples so far of this material not being, classified as biodegradable and staying in the soil. 90% biodegradable over 2 years, and it has to be 20 C. The soil has to be 20 degrees Celsius. So, I mean, that's not many places that in North America anyway that we, southern maybe, but can you comment to that?
Yeah, absolutely. I'm happy to comment on that because, and there'll be some data that we'll show in the next presentation that shows, at least in the conditions I'm coming from in Northwestern Washington, we do not see 90% biodegradation within 2 years. And so that's where part of our research team is trying to understand how do these films, not the feedstock material, which a lot of these standards are based on, actually behave in soils, when what is their actual residence time? Because a lot of these tests are made with just the raw feedstock, and it's oftentimes in a powder form. And what we're working with is a film that is only maybe 75 to 95% feedstock material plus additives. And so, with that information, we're just hoping to provide data, because that's our role, is not to promote technology, provide the information so that producers can make informed decisions. And then regulating and standardization bodies can then look at the data and potentially consider more realistic timeframes for the actual film material. Does that help address your question? Yeah.
Sorry. It also seems to indicate there's very limited places where this, even if you could get 90% biodegradable over 2 years, means you can't do it year over year or crop after crop. And I don't know why, because it's not
Yeah.
any cheaper.
Yeah, well, we'll have Suzette Galinato present a little bit more on the economics of it. We see in some situations it is more favorable economically. But yeah, again, it's still a material that is being investigated, and we still see and hear that it could be an opportunity for some producers, again, when recycling is maybe not available for them. And again, it's all about putting more tools in the toolbox. Okay. Yeah, Mark.
Lisa, can you just comment on, this is coming from someone who doesn't know much about the use of mulch films, like what mechanisms are there for the grower to know that they are buying a BDM material versus a standard mulch film? In other words, I was thinking about your slide that said you can't recycle this stuff at a normal recycling center and mix it with other recyclates, and what's the risk that somebody is using a BDM material and doesn't know better, takes it up, and then tries to recycle it? Is that like not going to happen because they know when they buy it, it's either way more expensive, or there's other mechanisms that would absolutely make sure that they know that this stuff only has to be tilled into the soil?
Absolutely. Yeah. In general, producers, when they're going out and purchasing a soil biodegradable mulches, they already have in mind the end of life would be in soil incorporation as opposed to recycling, or removal and disposal elsewhere. Also, the way that these materials behave, after deployment in the field, they start to weather, and if you try to remove a biodegradable plastic mulch, it is not like polyethylene mulch or some of the other, really great technologies out there that remove more cleanly. It fragments, it tears. So it's going to be a lot more costly for a grower to just physically try to remove it, because all the labor and challenges, because of it's just natural, not natural, but because of how it's engineered to perform that deterioration, the weathering, to kind of predispose it for that in-soil biodegradation process. In terms of how do growers determine what they're buying, it's really tricky right now. So that's why a lot of individuals on our extension team and elsewhere, we're really pushing for them to evaluate and look at the standards to make sure what they're purchasing is a biodegradable material and it meets at least ASTM D6400 or EN 17033. Because what we see a lot of times, if a product is labeled as biodegradable and it doesn't have any of the standards or certifications that I've mentioned, it's an oxo-degradable or a material that isn't biodegradable in nature. So I think I'm getting some body language from Jazmine that it's time to move on to the next presentation. Am I correct? Okay, great. Well, and then we switched it up. So I'll be going next, and then you'll hear from my colleague, Sam Wortman. The next presentation is about the behavior of biodegradable plastic mulches, and we'll be talking about deterioration, degradation, and tillage. Again, these are kind of flash talks, so I'll be here for the entire event through Friday. So if you have any other questions that are not getting answered now, feel free to hit me up anytime during this event. So first I want to just distinguish what deterioration and degradation are, because they're often used interchangeably, but they shouldn't. They are very distinct and different processes. So deterioration is the loss of physical or mechanical strength, and it's observed through physical testing, microscopic imaging, or what we typically do when we're evaluating a biodegradable mulch in our research program is macroscopic observation or visual-based observations of rips, tears, and holes. Then there's degradation or biodegradation, and that's the conversion or mineralization of the carbon in that polymer to carbon dioxide, resulting in a change of the chemical structure or physical properties or appearance of the mulch material. So we talked a bit about ASTM, and they define biodegradable plastics as plastics that degrade as a result from naturally occurring microorganisms present in the soil. So that's kind of the intention of biodegradable plastic mulches, again, incorporation in the soil and then biodegradation from organisms present in the soil. Polyethylene mulch, as we all probably are aware, is not biodegradable. It has polymers that have chemical bonds that microbes don't have the metabolic pathways to break apart, whereas the biodegradable plastics, they're made with polymers where microorganisms can access and break down those bonds by microbes. So biodegradation of biodegradable plastic mulches, it's affected by the material properties and the degradation environment, as we talked about a little bit earlier. When it comes to the material properties, we have physical and chemical attributes that affect the degradation mechanisms. And so some of the material properties will affect the absorption of moisture for that film, the glass transition temperature, or the rigidity of that material and how it becomes more flexible as temperature changes, and then cross-linking due to environmental weathering. And then we have the degradation environment, which, as we again talked about, is huge. And we have temperature, moisture, as well as microorganisms present, all part of that degradation environment that can affect the residence time in soil and the biodegradation. So I want to focus on two particular polymers that are used in biodegradable plastic mulches because they have very different behaviors in the degradation environment. So the first is polylactic acid, or PLA. So if you recall previously, this is produced from lactic acid fermented from renewable resources such as corn as one option by microorganisms. What I want you to pay attention to is the glass transition temperature of PLA. So it's 60 C or about 140 degrees Fahrenheit. And hopefully no one's soils regularly reach those high of temperatures. That's really warm, meaning that biodegradable plastic mulches made with PLA rarely get to that glass transition temperature where it's flexible and more accessible by soil microorganisms, whereas the composting environment does get to those conditions. So what we're seeing and what we're starting to share with our research is if you're looking at using a biodegradable plastic mulch, some of the materials that have a higher PLA-based content, we're not recommending for cool climate conditions because it's never going to reach that temperature in the soil where it'll reach that glass transition phase. The polyhydroxyalkanates, or PHA, this is a natural polyester fermented from renewable resources such as sugar by microorganisms. In contrast, its glass transition temperature is 5 degrees Celsius or 41 degrees Fahrenheit, and it degrades under ambient soil conditions. So this is a biodegradable biopolymer that would be more suitable for agricultural field applications, particularly if you're in cooler climate conditions such as the Northwest. So when it comes to monitoring biodegradable mulch properties, which we do intensively in our research program, there's physical and chemical ways that we use to measure at very strategic time points. So the first is during storage to ensure structural integrity before it is deployed in the field. We certainly don't want ourselves during our research or a grower cooperator or a grower for that matter to apply it and not have the physical characteristics that it needs for commercial production. Then we spend a lot of time looking in the field at its functionality. That's done through visual observations. And then we assess it in the soil afterwards to assess degradation in the soil environment and sometimes the composting environment as well. So a little bit about monitoring biodegradable mulch properties. This slide I'm going to just go over very briefly, but there's several different methodologies that we can employ. There's physical and mechanical methodologies ranging from tensile strength all the way to looking at the thickness and weight loss over time. And then we have chemical methods as well. And that table on the right just highlights a figure where one of my former students did a trial and looked at biodegradable plastic mulches commercially available in raspberry production system and compared it to polyethylene. And you'll see that the elongation and the breaking force for the biodegradable mulches are lower compared to polyethylene mulch, particularly at the end of its useful life frame. But this really is meant to serve an example as a lot of the same equipment and measurements that we make for degradable mulch films, we apply for the assessment of biodegradable mulch films. And then visual deterioration assessments. Those are probably the most practical and what we use regularly in our research program and what we advise crop consultants and growers to do as well as they're exploring or testing some of these materials out. So the first one that we employ is percent soil exposure. This is looking at a decrease in area over time. And then there's other methodologies as well, such as photography, colorimetry, macroscopic observation. And then we've also used various microscopic techniques such as on the right, scanning electron microscopy, where we can look at fissures in the mulch material over time and associations with microorganisms that might be potentially contributing to breakdown of that material. This is a good example of what we have seen so far with biodegradable plastic mulches in our trial. What we're looking at here is percent soil exposure. So this is, again, the amount of mulch covering a defined area of the soil. And we have that on our y-axis, and on our x-axis is time. I chose this particular trial because it's the longest period that we measured percent soil exposure in this raspberry production system. So the mulch was deployed in late May of 2017, and then we ended our measurements in April of 2018. So that represents a very long time where these mulches were deployed in the field. What we have here are 4 different biodegradable plastic mulches. Okay. Just try to show it. So these BASF 0.5 and BASF 0.6, and then Novamont 0.5 and 0.6. And then at the bottom here, we have polyethylene mulch as our control. So hopefully what you'll see here is at week 16, which is about end of September, is when we start to see an increase in the deterioration and the surface exposure of the biodegradable plastic mulches. And it increased over time with the arrival of winter conditions, whereas the polyethylene mulch remained intact. For this particular producer, it wasn't a problem because they plan to remove the mulch at the end of September in their production system. They just kept it longer for experimental reasons so we could see how long it persists in the field for this particular production system. And then a little bit about the degradation process. Essentially, the degradation process is we have a film, we deploy it in the field, it undergoes environmental weathering and deterioration, and it starts to fragment. Fragment is further accelerated when it's tilled into the soil. And then we have the formation of micro and nanoparticles, or micro and nanoplastics. And that's an important point that we have to communicate to people interested in this technology, that it does form microplastics and nanoplastics. The key is the fate and residency time should be compressed when using a biodegradable material. And then we have that material being metabolized by microorganisms, producing carbon dioxide as well as biomass of the microorganism. And this is a common slide that we use when we are presenting about biodegradable plastic mulches. That just shows the size range that we're talking about when we're referring to micro and nano particles. And then as I wrap up this particular presentation about deterioration and degradation, I wanted to highlight some additional data from our trials in Northwestern Washington. This is from a trial where we had 4 years of continuous biodegradable mulch application, and we tilled it in subsequently thereafter every year, and then we measured the amount of visible fragments in the soil. So this kind of goes to the question of how long is it persisting in the soil? Is it degrading 90% in 2 years? Is it longer? Because no one has generated that data. And so what we found in Northwestern Washington is presented here. On our y-axis, we have percent mulch recovery. And then on our x-axis, we have deployment first in spring of 2015, all the way through fall of 2014. All of the lines here represent biodegradable plastic mulches varying in the feedstock. And then the dark lines at the top, we have when mulch application occurred. So you'll see there were 4 application periods every year from 2015 to 2018. And then the dashed line represents when plots were tilled in, and then we have our sampling points represented by the lines. What this shows here is that even when we stopped applying the mulch film, we saw a continuous decline in the amount of visible fragments. Is it 90% in 2 years? No. And what our modeling efforts are showing is that in Northwestern Washington, we're seeing that 90% benchmark being reached in about 4 to 6 years. So really important data just to kind of advance the science and understanding of biodegradable plastic mulches. And then this is my last slide before my conclusion slide. And it just shows at the end of the experimental period in fall of 2020, after 4 years of biodegradable mulch application, what the team found with regards to visible fragments present in the soil at various size dimensions that you'll see here on this slide. So we have black polyethylene mulch as a control. In this trial, the investigators actually did till in black polyethylene mulch just to kind of understand how it performed in the soil and its residence time in the soil, and then to contrast it to the remaining materials, which are all biodegradable plastics. So with that, some of the conclusion and take-home points from this presentation is biodegradable mulches undergo deterioration, and that's an important first step before degradation in the soil environment. They do form micro and nanoplastic particles, but the fate and residence time is different relative to polyethylene mulch, which again, as we know, is not biodegradable. And then both deterioration and degradation can be measured in a variety of ways. We spent some time talking about those techniques. And then some of the big push and research efforts I see is continue to explore the longer term impacts on soil health, as well as kind of really narrowing down on what the fate and residency time is, and then communicating that to agencies that develop these standards. So with that, if I have time for questions, I'm happy to take some before the next presenter.
All right, we're here.
Is anybody looking at the rate of degradation and ways of, say, hastening that rate or increasing the rate? Because what, from a grower's perspective, what they want is that mulch to be intact and doing its job until they don't want it, and then they want it to very quickly change from a perfect mulch to one that is degraded 100%, right? And I understand that that's unrealistic, and you're talking about a very gradual degradation process. But are there ways of, say, increasing the rate of degradation in a shorter time frame? Say, I don't know, is there some enzymatic degradation that could hasten it? Is that being looked at?
Yeah, that's a great question. We get that one very frequently because it's a tall order for it to disappear like that. And the research is indicating that it doesn't behave like that. It takes time for that process to occur. There's been numerous trials. Jazmine's participated in them. I've led some where we've tried various products to see if it can accelerate that breakdown process. So far, we haven't seen anything with potential worth mentioning. You know, it's tricky, and this kind of goes into understanding what tools are available and when they might be suitable and when they might not be suitable. Sometimes what we've heard from producers is if the land is going into cover crop rotation, that it helps accelerate the breakdown process. Or, you know, they're a little bit more comfortable with having some of these biodegradable fragments remaining in the soil because it will be biodegrading in time. Whereas the challenge comes if it's rotating. If you're rotating land and say you have another producer that is expecting a very clean soil, they don't necessarily distinguish whether or not it's biodegradable or whether it's polyethylene mulch. And so they're kind of going back to your question, are there any materials that accelerate that breakdown process in soil? No, nothing right now. And again, we continue to try things and haven't found anything promising. I think there's a question.
Oh, I'm usually
I know.
has anyone done any testing to see if the plants or crops are taking up any of the microplastics?
Yeah, that's a really great question. Are plants taking up the microplastics? So there are some studies that show microplastic uptake, but realistically, the plants have a very efficient mechanism for controlling what is being transported into the root system and into the plant body. So plastics are excluded from uptake into the plants, but they can make associations around the rhizosphere, around the roots. And so that's something we're starting to look at. We have a graduate student on our team who's going to be looking at how polyethylene and biodegradable plastic mulches interact with that rhizosphere. And what is also the possibility for uptake in terms of like consumption. So like, for example, if you have a potato tuber growing with biodegradable plastic mulch and it interacts, is there the possibility for ingestion because of that interaction with the rhizosphere and that developing tuber? So I would say it's an emerging area of research. Okay. I'm going to stop and we're going to have our next presenter who Jazmine will be introducing. All right. Thank you.
Crop Productions. Do we have him? Perfect. And while we bring him on, just a little bit of background on Sam. So he's an associate professor in the Department of Agronomy and Horticulture at the University of Nebraska, where he leads the Grow Local Innovation Lab, and his team designs, creates, and tests new methods, ideas, and products to support local specialty crop growers and improve social, economic, and environmental sustainability on local food systems. His current research projects are focused on strategies for reducing and reusing plastic mulch film in vegetable and strawberry crops and the evaluation of biodegradable alternatives to plastic. So with that, we'll pass it on to Sam.
All right. Jazmine, can you hear me okay?
Yes, we can hear you. Thank you, Sam.
Okay. All right. So thanks to Lisa for the great introduction on BDMs, and then a little bit about how they degrade in soil. So what I'm going to talk about is some of those crop production considerations for what we can expect from BDMs relative to bare soil or polyethylene. All right, so thinking about BDMs as an alternative to polyethylene mulch, Lisa highlighted some of the shortcomings of polyethylene with regards to mulch disposal. So this conference, right, is primarily about plastic recycling, which our team and others are making great strides on, which is awesome. As you all know, one of the big challenges with recycling polyethylene plastic ag films is the amount of soil and plant debris that can possibly contaminate that. And so that's a limitation, and BDMs are a possible alternative to avoid that limitation. There's also waste disposal through landfilling and incineration that can be costly or limited depending on where you are. And then the plastics themselves and the end of life can be a source of environmental pollution if not disposed of properly. And then there's just the labor and logistics, so mulch removal time. There is some equipment that can make this go a little bit faster. This mulch lifter that you see on the right lifts the plastic from the shoulders of the bed top and then winds it up here. And that can definitely speed some of the labor, although you still have people driving the tractor. And then oftentimes you're going to have some tears. And so you're going to be starting and stopping and having to rewind some of that plastic as well. So there is still some labor involved there. And I'm sure some of the economics of that labor will be discussed in a later presentation. And then in addition to that, you've got some of that mulch, about 10% reportedly being left in the field. Some of that's just what gets torn and left behind on those shoulders where that plastic mulch film was buried. And as Lisa mentioned, that polyethylene is not going to be biodegradable in soil. And so that's just going to accumulate and be a source of pollution. All right, so to review, a soil biodegradable mulch should completely biodegrade, or at least 90% in 24 months in that standardized test. A lot of research to ensure that these products are not harming any soil ecology or health. And then from a production standpoint, what growers are really looking for is weed control, some type of temperature modulation, usually a temperature increase to help speed crop production and reduce that time to harvest. But we can also go the other direction with light colored mulches, and we can cool the soil. Oftentimes they're looking for soil moisture retention, just reducing that evaporative loss, same benefits we get from polyethylene. And then they're also want to make sure that if they use a biodegradable mulch film, that they're not sacrificing any type of yield benefits that they've come to expect from polyethylene. So BDMs are designed to be tilled into the soil after the use, as we've talked about already, that we don't want to be removing those. One, we're limited in doing so because they're not as durable, so they're going to tear when we try to remove them, and we don't want to contaminate any of those potential recycling pathways. We certainly don't want them to go in recycling facilities because they would contaminate that recyclate. All right, so time for biodegradation. Lisa covered this well. Climate and environment dependent, 4 to 6 years is what Lisa mentioned. And another product, and just to recap some of these certifications that we've seen start to pop up. So that Moder-B polymer is used to make a product that is more commonly available called Bio360. And so a lot of our growers here in Nebraska use this product or one like it. And you can see it's got BPI compostability, although most growers are not composting this, but as Lisa mentioned, that's just kind of the first certification that you get before moving on to biodegradable in soil. And you can see some of those based on those European standards that were developed recently. All right, this is a nice review adapted from Cowan and Miles 2018 that shows just how different BDMs are performing relative to bare ground or polyethylene in terms of 2 really important functions, which is weed control and effects on yield. So looking at different specialty crops ranging from broccoli to zucchini, we see that compared to bare ground, a plus sign here means that the BDM is performing better than bare ground. A minus would be performing worse than, and then equals, of course, equal to. So for most of these crops where there was data available, the BDMs are performing better than bare ground. And then looking at them compared to polyethylene, a lot of equal signs there, a few pluses, a couple of minuses, but seems to be kind of averaging out to be very similar to polyethylene. And when we look at weed control, where that data was available, it seems to be providing fairly comparable weed control as well. And all of these bare ground comparisons were weed-free. So it's not just that they were performing better than bare ground because the bare ground was a weedy mess. Those were weed-free bare ground plots. So there seems to be some other benefit that the BDM is providing, likely related to soil warming or reduced evaporative loss of water. The next few slides are some data from a meta-analysis that we published about 4 years ago. And the next figures will show the performance of BDMs relative to polyethylene mulch film. So in all of these figures, you're going to see a dashed line on 0. And that's just our reference point for where we would expect the performance, crop performance for a plant in polyethylene mulch film or soil underneath polyethylene mulch film. And so In this case, these values that are less than 0, these are percent changes relative to polyethylene mulch film. So here we're looking at different types of BDMs, starch polyesters being the most common. That would include Mod B, paper BDMs, bare soil, and then some just other types of biopolymer-based BDMs. So we find that BDMs have some soil warming benefits, but not as much as PE. So you look at bare soil and paper, and it would appear that paper really has no soil warming benefits. So BDMs are warming the soil a little bit better than paper, but not as much as polyethylene. Part of this could be due to the differences in thicknesses. A lot of BDM products are a little bit thinner than traditional 1 mil polyethylene, in part because of the cost of the polymer. So you might see a 0.9 or as low as a 0.6 mil BDM. And so that may influence thermal conductivity and transferring that thermal energy to the soil. But there's also just differences in physical properties, right? So the different polymers are going to have different capacity to transfer that thermal energy. And then like with polyethylene, we expect that color is going to influence that warming potential. So of course, those black BDM products do better than the brown and white, which have really no soil warming benefits. But again, even the black BDMs are still not warming the soil quite as much as polyethylene. And as Lisa has mentioned, that BDM by design really is less durable than polyethylene, and that certainly influences its capacity to suppress weeds, at least once you start getting beyond 2 or 3 months after mulch installation. And so when we look at differences in the weed density or abundance relative to polyethylene, those starch polyesters and other types of biopolymers tend to be 1 to 2x greater weeds. Now, there might not be a ton of weeds there, but relative to basically 0 weeds in polyethylene, we do see a slight uptick in weeds. You might notice that paper here is the only type of BDM that actually reduced weeds compared to polyethylene. And that's because many studies look at the use of paper mulch specifically for controlling sedges, which are a big problem in any type of mulch film system, because those sedges are really good at growing through a film. And so that's why this data shows kind of this net positive of paper. And then our crop yield data seems to correspond well with the table that I showed you from Cowan and Miles, in that despite maybe slightly less soil warming potential and that later season drop in weed control, we really don't see evidence for big differences in yield. And so these would be products like Mod B, where we see the yields are right on par with polyethylene, and the same is true for those groups of other biopolymers. And then lastly, I just want to mention a little bit about the USDA National Organic Program, because we get a lot of questions from growers when we're talking about BDMs about, can I use this on my organic farm? And it's an understandable question, right? Because when you think about just the approach and the thinking behind a BDM relative to a polyethylene film, it seems that a BDM would be philosophically maybe more in line with the National Organic Program, but the rules don't necessarily line up with some of that philosophy. And so a biodegradable bio-based mulch film was added to the list of allowed substances in the National Organic Program in 2014. But the rules that follow basically make it so that there are no commercially available film-based products that can be used on organic farms. And that's because it has to be 100% bio-based. It has to be produced without the use of any non-bio-based synthetic polymers. So as Lisa mentioned, many of those commercial products, or really all of them, do include some synthetic polymers. And so that precludes it from use in organic systems. You also can't use any GMO-based feedstocks. So a lot of these biopolymers are made with genetically engineered corn. And so that's problematic for organic standards as well. And then, of course, it has to meet those same compostability and biodegradability in soil standards that Lisa mentioned, which, depending on the product, and especially for something that has a higher bio-based content, like 100% PLA, for example, it's not possible to achieve those standards. So again, a lot of the feedstocks are problematic with regards to corn or even sugar beets and the sugars that come from that, because most of it's genetically engineered. And then it's also difficult to determine the GMO status of the end product. Oftentimes the source of the feedstocks is not disclosed by the companies who are synthesizing things like PLA or PHA. So that's kind of a dead end for allowable use in organic systems because they demand transparency in that production pathway. And even if you wanted to test the end product, it's not possible because that DNA gets degraded during the manufacturing process, the fermentation, and subsequent processing of the product. So as a result, that's a long way of saying that there are no plastic BDMs that are approved for use in certified organic production. Really, the only BDM that is on the OMRI list currently is WeedGuard Plus, and that is a paper-based biodegradable mulch. And I guess one caveat is that we do have a few growers in Nebraska who are certified naturally grown, which actually follows for vegetable production, follows the USDA organic standards, with one caveat, and that major caveat being that they do allow for the use of biodegradable mulch films on certified naturally grown farms. And so it's a very small kind of niche certification program, but we do see an increasing number of growers going towards that, in part because of BDMs. All right, so same acknowledgements that Lisa had, so I'll skip right to the questions if there's time for any.
Do we have any questions?
Seeing as there's none, perhaps you could you expand a little bit about, because I was listening to this and I just want to get my head around it. I think you said on the organic growers, for the most part, mainly because a lot of these biodegradable mulches are made from GMO crops. But I think at the end you said that there was one that is available or it does work. Yeah.
Yeah, so there's there is a product called WeedGuard Plus and others like it. The DeWitt paper weed barrier, I believe, might also be listed. And those products are just 100% paper. So it's just a cellulose-based product, no genetically engineered feedstocks, but a very different product, right, from the films that we're talking about in terms of their thickness, their cost, and the overall performance. So the big thing is you lose the soil warming benefits in that product, and it's heavier in its weight basis and its thickness, and so it's more expensive, and so it's not really, it has its place for sure, but it's not really a one-to-one replacement for polyethylene per se in terms of its function.
Okay, and just to follow up to that, because I'm not that knowledgeable about the organic growers, but I just know they have to go through a lot. So they could not use any mulch film at all as an organic grower. Is that correct?
So it's a little counterintuitive, but organic growers, produce growers, commonly use polyethylene plastic mulch film. Now they have to remove it entirely from the field at the end of the season, which in practice is very difficult. And that's actually the same guidance that I've heard from many certifiers regarding BDMs as well, that it could, in theory, if you look closely at some of the language, you could, in theory, use a BDM on a certified organic farm, provided you could practically remove it from the field at the end of the season and you're not planning to incorporate it in the soil, which the economics kind of fall apart at that point, as I'm sure Suzette will talk about. But so the reality is that we're not seeing any organic growers use BDMs, but many of them do use polyethylene mulch films.
Great. Great, thank you. Well, with that, we've come up to the wrap of that 15 minutes. But again, Sam is based in Nebraska, and for our biodegradable mulch project, or soil biodegradable mulch project, he leads the trials out in Nebraska. So if anyone has any additional questions, you can find him via email. Great, thank you, Sam. And next, we're going to hear a little bit more on the economics of soil biodegradable mulch use from Dr. Suzette Galinato. She is an assistant professor and extension specialist in the Agriculture and Natural Resources Program Unit within Washington State University Extension Program. And she's an agricultural economist with program areas focusing on farm financial management, and economic feasibility, analysis of adopting new technologies, and novel or improved practices for agricultural crop production.
Hello.
Welcome, Suzette.
Hi, everyone. Thanks, Jazmine, for the introduction.
Yes.
I'll just share my screen. So good afternoon, everyone. In this presentation, I will talk about factors to consider when transitioning from PE mulch to BDM. Also, I will touch on the conditions where BDM use is a more profitable option than PE mulch. You will find most of the information that I will share with you this afternoon in the Small Fruits website under Plastic Mulches and Teaching Materials. Putting together this material is a team effort, so I'd like to acknowledge Margarita, Srijana, Shuresh, Lisa, and Mark for all their contributions. Okay, so to go over the overall economic considerations when adopting an alternative practice or technology, agriculture producers have incentives to adopt these new technologies or practices such as BDMs. Examples are improvement of production efficiency and crop yield, reduction of negative environmental impacts of production practices, and increase in farm profitability. In general, it is important to consider the following factors when deciding whether to adopt a new technology: cost of adoption, which include material and labor costs; benefits like increased crop yield and cost savings in production inputs; and net profit, which is the difference between revenue and costs. Producers must account for specific benefits and costs of technology adoption and compare the net profit to that of standard practice. The overall picture is important. Which practice generates a higher net profit? If the alternative generates a higher net profit, it means that it is more profitable than the standard practice. Do BDMs cost more than PM mulch? The answer is yes. In this table, the material cost corresponds with the dimensions and thickness. Plastic or paper BDMs can be at least twice as expensive as PE mulch. The costs here do not include shipping. In the next slides, I used plastic BDM in the analysis, which will be referred to as simply BDM from here on. Since BDM is more expensive than PE mulch, a producer needs to know potential savings with BDM use in order to assess if those savings offset the cost of the product. So first, account for the material cost of PE mulch. Second, estimate the costs of both operator and manual labor for mulch removal, and estimate the amount or weight of plastic to be removed at the end of the growing season. Third, estimate the labor cost and the disposal cost after removing the PE mulch from the field. Disposal cost includes transportation and landfill disposal fees. These costs vary by location. For example, as of 2023, disposal fees range from $50 to $93 per ton in California, $55 to $99 per ton in Washington, and the national average is about $58 per ton. Some landfills may not even accept PE mulch for disposal. When using BDM, the primary expense is the purchase of the product. There are no mulch removal and disposal costs. However, not all end-of-season activities will be eliminated. With PE mulch, drip tape is pulled up together with the mulch. With BDM, there is no mulch to pull up, but trip tape must still be removed before tilling BDM into the soil. Tilling BDM into the soil will involve operator labor, but it may not be an additional cost if tillage is one of the typical activities done at the end of the growing season. Now, let us consider a hypothetical scenario to illustrate the economic feasibility of using BDM in crop production. We are going to focus on changes in income and expenses and calculate the net change in profit by using BDM instead of PE mulch. On the left are the benefits or positive financial changes when using BDM, represented by any additional income and reduced costs relative to the baseline. Under additional income, we assume no changes in output price since currently there is no price premium for products grown on BDM. We also assume no change in yield due to the use of BDM, as many studies show they are similar. Under reduced costs, there are potential cost savings due to the elimination of end-of-season activities like PE mulch removal and disposal. On the right, our costs are negative financial changes when using BDM, represented by any additional expenses and reduced income. Under additional costs, BDM is more expensive than PE mulch, so we will include here the difference in their material costs. BDM is tilled in the soil, but we assume that tillage is a typical end-of-season activity, therefore no additional tillage costs are incurred. Under reduced income, there is none because of the assumption of no change in output price and yield. We list the following assumptions to estimate the difference in net profits for PE mulch and BDM, such as the thickness and size of each roll of mulch, quantity required given bed spacing, the cost of mulch, labor hours to remove and dispose PE mulch, labor cost, disposal cost, and the quantity of PE mulch collected at the end of the season. Let us populate the table with some numbers. There is neither additional nor reduced income because there are no changes in output price and crop yield. In reduced costs, we have about $271 per acre of labor cost savings by eliminating the need to remove and dispose PE mulch. That is 15.75 hours multiplied by the hourly rate. Disposal cost savings is about $8 per acre, which is derived by 0.13 ton multiplied by the disposal fee. In additional cost, BDM is more expensive than PE mulch. We have $190 per acre, which is the difference between the material costs of BDM and PE mulch. The net impact of the change is positive. Based on the above assumptions, using BDM will increase net profit by about $89 per acre. Now, in the next few slides, I will show how changes in net profits vary, excuse me, when costs for BDM and labor change. In the first figure, we have the material cost of BDM on the horizontal axis. On the vertical axis, we have the difference in the net profit of using two different mulch types. Therefore, when the difference is positive, it means that using BDM is more profitable than using PE mulch. In this graph, we only vary the price of a unit of BDM, while the revenue and all other variables are held constant. When the price increases, the profitability of using BDM decreases. For example, when BDM costs $265 per roll, there is a gain of $189 per acre when using BDM rather than PE mulch. But when the cost is $390 per roll, there is a loss of about $61 per acre. There is neither a loss nor a gain when the mulch costs about $359 per roll. What are the potential changes in net profit if we vary the labor hours for removing and disposing PE mulch, but holding all other variables the same? When these labor hours increase, the labor cost savings become higher with using BDM because these activities are eliminated. Therefore, such scenario translates to BDM use being more profitable. For example, if 22.25 labor hours per acre are needed for PE mulch removal and disposal, the net profit associated with using BDM are higher than that of PE mulch by about $175 per acre. However, if 7.25 labor hours per acre are required, the net profit is lower than that of PE mulch by about $83 per acre. The difference in net profit is 0 at 12 hours per acre. What if the required labor hours are the same, but we vary the labor rates? This map shows adverse effect wage rate, or AEWR, as of 2024. It ranges between $14.53 to $19.75 per hour. The lowest are in 3 southern states and the highest in California. For the calculation of change in net profit, I use the US median rate of $17.20 per hour. This figure shows the sensitivity of the difference in net profits between the alternative mulch types given different labor rates, while holding all other variables the same. In the horizontal axis from left to right, we have the minimum, average, median, and maximum labor rates. There is no difference in net profits when labor rate is $11.60 per hour. This means that when the hourly labor rate is greater than $11.60, it is more profitable to use BDM. This scenario highlights the potential benefits to growers of using BDM as alternative to PE mulch when the prevailing wage rates in their area for agricultural workers are high. Some additional notes about labor. Especially in small operations, the farm owner is often responsible for cleanup activities, and these hours are often not considered a direct cash expense and may be overlooked. This unpaid labor must be included when estimating total labor costs to assess the monetary value of end-of-season activities more accurately and to help plan for scenarios where owners may not be physically able to do this job and may have to hire workers. For farms employing migrant workers, if their labor hours are reduced, workers may decide to go to another farm that will employ them for more hours per season. Therefore, although labor cost savings are important, it is also important to be aware of any unintended consequences of reducing workers' hours at the end of the season. There is also an increasing trend in the costs of labor in agriculture. The national expenses for hard labor are projected to increase by 7% in 2024 compared to its level in 2022. The national average adverse effect wage rate increased by 13% between 2022 and 2024. So what are the main points to take away from this presentation? Since BDM is more expensive in general than PE mulch, should a grower still consider using BDM? The answer is yes, considering some important factors. The clear benefits of using BDM are in terms of the elimination of end-of-season activities associated with PE mulch, particularly removal and disposal costs. The use of BDM is potentially a more profitable alternative than PE mulch given one or a combination of the following: low to moderate material cost of BDM, high labor requirement to remove and dispose PE mulch, and high farm labor rates. In assessing whether the use of BDMs is economically feasible for our farm, there are 3 critical factors: the costs, benefits, and net profit, all compared to what can be realized in the standard practice. The third factor is the most important overall. If producers focus only on costs, they will be unable to take advantage of opportunities or benefits that can improve their net profit. Although producers are relatively concerned about costs, it is net profit that keeps them in business. And a positive net profit due to a change in practice can be achieved when benefits outweigh the costs. Before ending my presentation, I'd like to share 2 economic tools that we developed to assess the feasibility of on-farm adoption of BDM. They are publicly available in the website. First is a mulch calculator that calculates the quantity of mulch needed and provides cost comparison between BDM and PE mulch. To use it, one must enter the spacing of plants between bed centers. The requirement calculator will then generate the required quantity of mulch for different lengths of mulch. Then the cost calculator sums up the machinery cost, material cost, and relevant labor costs. Second is the mulch use flowchart. It calculates and compares the gross profit when using PE mulch, BDM, or bare ground. The user will enter the costs and revenue associated with the mulching practice. We developed these flowcharts for pumpkin, strawberry, and raspberry, but the charts are customizable so they can be used for other crops. I apologize for the screenshots of economic tools in the previous slides because I can only fit a portion of them. Here I provide the websites where they can be accessed, plus other references for your information. if there is time later and interest, I can demo one of the tools or both. So thank you for to USDA for funding the project, and thank you all for listening. If you have any questions, if there's time, I'd be happy to answer them.
At the end of the season, when you're deciding, you're talking a lot about savings at the end of the season.
Oh, I'm sorry, I can't hear you clearly.
You're talking about, can you hear me now?
There's
still a problem.
Yeah, still having trouble hearing. I'm sorry.
Maybe you can repeat it, Jazmine. So at the end of the season, talking about savings because you're just disking in the biodegradable mulch. I can only speak to the, okay, this will work better. Hopefully. Okay, so at the end of the season, your the situations that I've seen, we did test one biodegradable mulch at Cal Poly on our farm, and that mulch looked very similar to the day it was laid at the end of the season.
Okay.
So when you're talking about going on to the next crop, I don't see how you can incorporate that mulch into the soil easily. It would bind on basically any piece of equipment that you put into the field. So is that something you're seeing as well when you're testing these materials, or is it rototilled? What piece of equipment are you using to incorporate it into the soil so that you don't have to have a crew removing it just like you would polyethylene mulch?
Yes, thanks for the question. In the field studies that we've done, and Lisa, you can add to these too, they've used a rototiller to till BDM into the soil. And in those field studies, I've observed that the BDM is not as intact as what you've seen in Cal Poly. So I can imagine how hard it would be to till into the soil something that's intact. Yeah, so I guess it will depend on environmental conditions, maybe the BDM material too that's been used in a particular field in order to observe any cost savings by being able to till the material into the soil.
And I can comment further because we don't have data on this, but it is a concern that we've heard from growers. But we've asked producers in Europe that have used biodegradable mulches for 20 years. We've looked at it in our own trials. And even with a biodegradable mulch that is fairly intact, covering the soil surface, the process of deterioration just weakens the polymer. So we have lower elongation and it breaks a lot more easily. And we've never seen issues with binding. We've never had any issues reported with it binding on rototillers. So it's just not been an issue in any of the work that we've done, nor has it been an issue for growers that we've met throughout North America and in Europe that have had a history of using it.
So a follow-up question, does it then fragment if you've got something that is degrading readily? Is it in many thousands, millions of fragments that then are liberated by wind and end up on the fences and in the ocean, and people don't distinguish between, say, a piece of biodegradable mulch that is blowing around and a polyethylene mulch?
Yeah. Suzette, do you want me to answer that too?
Yes, please.
You're asking the research that we're doing right now, or we're starting to do windblown films. That's something that we're starting to explore in partnership with other team members. Kind of going back to your question, let's take, so can you repeat your question is more like windblown fragments, and that's something that we're looking at.
You have two extremes, right? In the one extreme, it doesn't really degrade sufficiently, and then it's difficult to incorporate. And on the other hand, if it's degrading readily, you end up with maybe lots of fragments, and it seems likely that those fragments would be liberated.
Yeah.
So, most of it would get incorporated depending on the method you're using, but some of it
Right.
would be, on a windy day would end up who knows where.
Yeah, and that's research that we really need to do because no one to date has looked at windblown fragments. So there's certainly the potential, and then I would say the actuality that some of the biodegradable mulch fragments, when you're incorporating it in the soil, it does move. All of us can attest that it moves off-site. And what are the broader ecological implications of that? We're still trying to understand that so that, as we move forward and we present and share information about biodegradable mulches, the producers that end up making decisions on adoption have all the information, pluses and minuses available to them. But it does blow the incorporation piece is really interesting. And I think Sam we've had conversations. It'd be interesting to look at, the tillage and the particle size that you're generating through the action of tillage and what that means longer term in terms of the residency of that material in the soil and in the larger environment. That work just hasn't been done yet. So these are all, you're asking our next research questions. So if you want to join the next project proposal, let me know.
And in the chat, Shuresh mentioned that he can touch on windblown fragments during the panel based on growers' experience.
I had a related question. I was wondering, similar to windblown, is there issues with it kind of migrating off of the field in stormwater with like heavy rains, et cetera? And at what point, like if it does get into stormwater and then into local rivers or streams or creeks, does it continue to break down, or does it just then, if it's not in the soil or under certain conditions, does it just float?
We've actually, we did some work on that. Our concern of it going out into the ocean, and we saw that it was breaking down in the ocean conditions. So we did see that, but in an effort of time, you guys sort of moved us right well into our next panel discussion, which is actually going to cover some of the questions that you guys have. And Gerald, of course, as you know, and we talked last week, the Cal Poly team is actually joining us in this new research project as well as WSU. So we're excited to be exploring that movement and those hot spots to look at what practices can help with that. But before we get started on the panel questions, I want to introduce our panel. And so here with us, we have Rich Udo, who is a grower and owner of Satsuma Farms. He's a medium scale grower of organic and conventional strawberries in Central California. Oh, I'm so sorry. Oh, sorry, we still have another talk. You'll have to wait on the panel discussion for a little bit more. Okay, so next we're going to be hearing from Shuresh. In his role as an assistant extension educator and extension vegetable and hemp specialist for Yukon Extension, he works responsibly for vegetable and hemp extension programs for the entire state of Connecticut. And his current research focuses on extension outreach focused on vegetable and hemp integrated pest management, climate adaptation, nutrient management in high tunnels, biodegradable plastic mulch, and in designing, implementing, and evaluating online courses and web-based materials for extension audiences. Shuresh will also be part of our panel, so we'll get to talk a little bit more about the questions that were currently being discussed. Go ahead.
Thank you, Jazmine. Can you hear me okay?
Yes, we can hear you.
Awesome. Yeah, thanks for organizing this and inviting me to contribute. I'll be, through this talk, we'll be talking about impact of soil biodegradable plastic molds on soil health. Let me dive right into the presentation. This is the last one before the panel, so I don't want to be a hold up. So defining soil health, I would like to compare soils in agriculture to hearts in humans. If we want to keep the agriculture sustainability, we need to keep our soils healthy. Likewise, if we need to have healthy life and live longer, we need to keep our hearts healthy. That's the analogy I like to use. Soils are the foundation of the agriculture sustainability. USDA NRCS defines the capacity, soil health as the capacity of the soil to function and deliver ecosystem services to sustain biological productivity, maintain environmental quality, and promote plant and animal health. Soil health, it's a big term. So in order to make any assessment around soil health, there are strategies. That means dividing into smaller components and measuring those parameters. Soil health can be assessed through physical soil health, chemical soil health, and biological soil health. And under each of those categories, as listed here, under physical, bulk density, infiltration, penetrometer resistance, water holding capacity, aggregate stability, those would fall under physical soil health parameter. How does mulch affect soil health? We heard a lot about comparable yield, slightly decreased soil temperature with maybe black BDMs, but somewhat comparable, lots of those benefits. But it also has benefit, or it also may have impact on soil health, again, dividing into those smaller components. And then we'll dive deeper into some of those small details. This has been discussed, so I'll just quickly reiterate. Mulches would modify soil temperature, may increase or decrease based on canopy coverage or color of the plastic film, and can also modify soil moisture depending on, most times it's gonna save the soil moisture, but at times when you don't want too much rain falling into the root zone, raised beds coupled with plastic molds can save the rain and even like keep the soil a little bit dry. So it has both sides of increasing soil moisture and decreasing soil moisture depending on the strategy to use it. And all of these will have impact on soil quality. So USDA Soil has designed a soil quality test kit and guide that can be used in field to measure some of the parameters that I mentioned. Again, dividing the soil health for the comprehensive assessment. All of these indicators, if you see on the first here, structural indicators, aggregate stability, soil slacking, bulk density, and likewise, those all can be measured and will provide a comprehensive assessment of the overall soil health at the end. So this was, so I'll start from the study that I was involved as a graduate student at Washington State University and in collaboration with University of Tennessee. We tested 4 BDMs, paper molds, polyethylene molds, and bare ground as control. And we looked at, in addition to yield, crop quality, we also looked at some of the soil quality parameters. And what I'm going to present here is going to be a summary of 2- and 4-year studies that measured some of these soil quality parameters that I mentioned: pH, organic matter, nutrients, bulk density, etc. So we're looking at the soil aggregate stability, and what you're seeing here on the left side of the graph is from Tennessee, Knoxville, Tennessee. Pretty warm summer, cold winter. Mount Vernon, Washington, pretty mild summer and mild winter climate. So within each site, there was no significant difference in the soil aggregate stability between the mulch treatments. You see paper by these BDMs, they all share the same later. That means there was no difference in the soil aggregate stability. But you see, bare ground had little less soil aggregate stability. And in in Washington, there was no difference in soil aggregate stability due to mulch treatment. So this only 2 years of data, but this indicates there is no change in soil aggregate stability in short run by using different types of BDMs. So this is soil microbial communities plotted as a principal component analysis. So different colors indicate different years or seasons. For example, pink is here represents spring 2015. And again, this side, left side is Tennessee and right side is Mount Vernon, Washington. Each dot represent a community of microbes. If they are closer, that means these are similar communities. So what you see over here is those dots are closer by color. So I mean, those are more associated with seasons and years rather than the mulch treatments, which would be shapes. Shapes are all over the place with no any pattern, but the colors are somewhat segregated in a pattern. So there was no difference in microbial communities due to use of these mulch treatments versus including polyethylene and paper mulch and no mulch. There was no difference in soil microbial communities, but what was different was due to season, years, and by locations. So this is scanning, zooming into scanning electron microscope SEM images, and what it shows is some of the mulch surfaces host some bacterial communities, bacterial populations, indicating mulch surfaces may provide a favorable environment for microorganisms. And this is later supported by other studies as well. Looking at organic matter, there was no change in organic matter over 3 years period due to mulch treatments. And again, compiling all of those smaller components into overall total soil health function. Again, you see all these different mulch treatments aligning in a line here with a little bit more standard deviation on these box plots for no mulch in most of the cases, but pretty much same. So overall soil health function, which is combination of all those parameters, did not change for this study period. What changed was these soil health functions change over seasons and maybe over different locations, but not due to mulch treatments. So there are ongoing field trials, and I'd let Lisa and others comment on these if you have any questions. But we are this project is continuing to do quality assessments, soil quality assessments after BDM incorporation in fields. So the take-home message from my presentation is use of different BDMs did not negatively impact overall soil health over the period of 2 or 4 years, depending on what parameters we looked at. They varied more among sites and seasons, not among the treatments. So it is, again, just reiterating, can be a promising technology, but there is a caveat. There is concern that how the soil quality would behave after long term. We'll hear from other growers in the panels, and I'll also share some of what I heard from growers regarding those. But scientifically there is still concern about long-term sustainability of these products, especially over soil health. These are some of the resources utilized in making these presentations. That's all I have.
Thank you, Shuresh. And now we'll move towards our panel discussion. And Shuresh is going to be part of the panel, so if you guys have questions, we could address them during that discussion. But I also quickly want to introduce with us, we have Rich Udo, who's, as I mentioned, a grower for Satsuma Farms. He's a medium-scale grower of organic and conventional strawberries across Central California. And he's a grower partner with California Giant. He's a leader in the industry when it comes to pioneering and collaborating with research on practices designed to improve the sustainability of strawberries growing operations. And he currently is trialing new mulch technologies, including soil biodegradable mulches and mulches with improved recycling outcomes. And we often refer to him as the grower for the face of plastic culture because he's been so involved. So thank you, Rich. And Trevor Hardy also joins us. He's the farm supplies manager, systems engineer, and assistant crop production manager for Brookdale Farm Supplies. Oh, there he is. Hello. He is a 7th generation fruit and vegetable farmer with a degree in industrial engineering. And he is the current president of New England Vegetable and Berry Growers Association, as well as president of the Hillsborough County Farm Bureau. He built and operates Brookdale's Farm Supplies, the largest irrigation and row crop supplies company in New England. And his focus is on change in industry towards no-till vegetable production, high-density apple production, and the implementation of lean principles on farms. Great. Thank you, Trevor. We see you here. Thanks. And so we'll start with a question that I think a couple of you in the audience here brought up today, which is that obviously there's some challenges with the technology of soil biodegradable mulch. So I would like to get feedback from our panel today on what you perceive to be the dropbox or cautions that you would express for anyone interested in using biodegradable plastic mulch. And for those Dropbox, are there any ways that you think we could overcome some of those challenges? And we'll start with Rich.
So biodegradable mulch, in California, we produce 90% of, I don't know if it's the world, but at least the US amount of berries coming out of this state of California. But anyways, getting to the point about BDM, there's a process prior to that. Like if you're going to grow berries, you're going to have to use a fumigant. So with biodegradable mulch, the only drawback is actually you got to go in there and they call it flat fume, where they put more plastic out there to fumigate the ground. And it looks like a sea of white. And then next thing you know, they got to take that. And I think they use like it's a TIF, and I think it's 6 mils. It's pretty clean. I'm surprised that they don't recycle that because it's probably on there for about the maximum of 2 weeks. But then you got to put the BDM after the fact. I love the fact about the BDM. I was listening about the microplastic and this and that. Well, you know what? I won't be honest with you guys. If you see berries anywhere, soil is contaminated already with standard mulch. That's the bottom line. You see macroplastic, microplastic, they're flying everywhere. I see it on the fence, and that could have been from 20 years ago when they were putting out mulch for the first time. Because that's, it's just there. It's just contaminated. But moving forward, let's talk about moving forward. I think BDM is a way of doing things. And there's certain things that we can do. Like you were asking about the kind of equipment that we might use. We're going to have to definitely disc it in first and probably go in there and work in the BDM, disc, chisel, and maybe do that passive rototiller, wherever it takes. And then, you're talking about making sure the plastic stays. Well, we might have to throw some pipes out there and sprinkler irrigate it so we can keep the plastic from not going out and really moving anywhere. Now, if it rains, it's not going anywhere. It's going to get embedded in the soil. So anyways, that's my thought about the BDM. And, you know, doing the trials, I don't have a problem doing the trials. I'm excited about it all the time. This year, I wasn't a grower trying to do the trial this year. I think I did it where more was like more of a test. And so in reality, this is my first year I tried it because I went with these shorter runs and the plastic was so difficult. And they're 50-foot runs and they were too short and they never got going with my mulch laying machine. So it kind of wasn't the best thing. But I'll tell you right now, you look at the BDM right now with my production, there's no difference between that and my standard mulch and all the different types of BDM. Now Jazmine's mentioned the fact that, you know what, we need to go with the thicker BDM, but I don't know if we need to really go with the thicker BDM. I don't. I think it's okay. It's just the way I put it on, and I got to get better at kind of doing that. And right now, I don't know if I should say this, but I'll say it anyways. I'm going to go with this year. I'm putting 100% of solar shrink on. And the reason why I'm doing that is because I really have no answer, but I know that solar shrink, we're using less plastic. And then with solar shrink too, they got the TIF, they got the TIF, you know, solar shrink mulch. So, and that one, it's at 0.9, which with my standard mulch, I'm using 1.5 mil. 1.5 mil, that roll is super heavy. You know, maybe 10 years ago, I should pick it up, but I won't even touch it now. But it's super heavy. I can actually pick up that, you know, the TIF 0.9. I can kind of pick it up because it's so much lighter. So that means for I had a simplistic approach. I go, listen, guys, we're using less mulch. That means that less is going wherever it's going to go. Because, you know, we say we're going to try to recycle it, and that's the goal. You know, I use a mega binder. I used it for the first time last year. It was awesome. Saved me a lot of money if we're talking financing, because I didn't have to have like 100 people out there looking like a bunch of goats going out there and pulling plastic, because basically that's what it was. So that being said, I think, you know, I think BDM, it has a chance, but they're gonna have to figure something out where with the fumigants and all that kind of good stuff. And, you know, you got to do it organic. You got to find a way to do it organically. And it ain't going to be paper, that's for sure. Because then, think about organic, you can imagine what kind of weeds you got coming up. So that's, again, my simple thought on all that. But there's the good thing is, and you guys are all intelligent in here, so hopefully you guys figure something out in my lifetime of growing. That's all I got to add.
Great, thank you, Rich. And I'll pass it over to Trevor.
So hi, everybody. Trevor Hardy here from Brookdale Fruit Farm and Brookdale Farm Supplies. So I'm a 7th generation fruit and vegetable farmer here in New Hampshire, and we happen to own the largest row crop supplies company in the Northeast. We do around 120 to 160 acres of row crop vegetables on plastic annually. And I've been using biodegradable mulches for over 20 years. We started with Bio 360. That has had an industry trade change name, which is now called BioGuard, because it was originally manufactured by PolyExpert. There's been a huge price change in the market for those of you that haven't paid attention in 2024 compared to other years with the cost of film. And 65% of our growers in New England are using biodegradable mulch. We have a lot of organic growers that aren't doing that, but my sales have changed in the Northeast region, which is around 20 to 25 truckloads of film every year, to 65% bio-based. And the majority of the growers have signed on. 10 to 15 years ago, we were selling a lot of lifting and winding implements for traditional film. And growers, what they would do is I'd say, hey, try a roll. Don't change the whole farm. Any farmer who's conscious of their growing conditions is going to try a roll or two before they go all in. And everybody has different soil conditions, growing conditions. the biggest thing that affects biodegradable mulches is organic matter. So the standard up here, at least in the East, is we start with a 0.6 biodegradable mulch. Try that on an acre or two, see how it degrades. The higher organic matter content or moisture, the thicker the film you have to go with. One of the bigger changes in the last 5 to 8 years that we've seen is end of season incorporation. Everybody up here is putting a cover crop and putting their fields to bed for the winter because we only have one growing season that we can achieve on the field. And that change has been, we're not using harrows to incorporate biodegradable mulches. We're typically using reverse tiller stone barriers now. And that reverse action, which is spinning the opposite direction of a rototiller, actually buries the fragmented bioplastics in the soil, and then you can either no-till drill or spread a cover crop on the top. And there's nothing bigger than a quarter the next spring. Once you turn the soil over again the first time, it's gone. I have never had a grower try a roll and say, no, that's not for me. That's why the majority of our market is changing and focusing on this. Again, it's the certified organic folks that aren't doing that. And we've had a lot of organic growers switch from the same previous mentioned certified organic to certified naturally grown just to save the plastics and the cost of that material from going to landfills because they recognize it's better for the overall ecosystem. So yeah, we don't see drawbacks in the Northeast. It's ever increasing, and that use is expanding all over the place. And just to explain a little bit on the price difference in 2022 and 2023, a typical roll of 4x4,000 0.6, we were seeing prices in the range from myself and other distributors up here around $260 to $280 a roll. 2024, the average price for that same roll dropped to $228, thanks to some innovation in the market. And before we sell something personally at our place, I've tried every single biodegradable mulch in the industry that is currently out there right now. And there's 2, possibly 3 that we recommend. We push 2 very hard. And if the growers say, hey, a farmer has been using it and using it to their success, that's what sells it the most, is word of mouth of the farmers. And the cost savings from that other presentation, I believe, are vastly underrated. Once a farmer develops a system using this plastic, you won't go back. And in our area, the largest strawberry producers, Norse Farms, all our June-bearing strawberries, we don't grow a lot of day neutrals up here. All of that June bearing is done on establishment of biodegradable mulch, and it just decomposes the first year and gets rid of 80% of our weed costs. So yeah, use it.
Great, thank you, Trevor. Shuresh, is there anything you would like to add?
I'd just like to share a couple of examples I heard from growers. I think that would be relevant here. Last week, I visited a farmer who grows watermelons, and his watermelons were not on any type of plastic mulch. It was just on bare soil. It had a cover crop before, so it wasn't completely bare. And the reason I asked why don't you use any sort of plastic mulch, or I was particularly interested in BDMs, and his experience is his neighbor used BDMs 10 years ago, and he is still seeing fragments around the fences. So that's his experience. I've heard a similar experience from another grower who used BDM but stopped using it now because of the complaints from his neighbor. Those are just 2 examples. Just keep in mind the number. But all the farms I visit, and many farms who use BDMs, when we walk the field with farmers, we don't see very many fragments in the BDM fields. We see more fragments in PE mulched field where supposedly all of it had been removed, but we still see more PE fragments. And the farmers who have been using it are happy. And as Trevor said, one farmer even told me, I would not go back to PE mulch until the price of BDM per roll goes beyond $500. I will keep using it because that's the economic benefit they get from BDM. They don't have to rush and pick it up toward the end of fall, where there is time crunch in harvesting everything, cleaning up equipment, because they can just go right in and till it in and put a cover crop down. And if they don't have BDM and have PE mulch, sometimes they miss that window to plant the cover crop, which is really important in our region. So many benefits, but some of the concern and fear I'm hearing is not necessarily from growers who have used it for at least more than 2-3 seasons, but just scared from hearing incomplete information from neighbors or friends. That's my impression.
Great, thank you for sharing that. And next, we'll move on to a question that a couple of you from the audience, I believe Mark and Gerald both brought it up, which is, and Lisa talked about this a little bit too, which is how do we address the concern from the general public that they might not be able to discern between whether a mulch is polyethylene based or biodegradable, and they might be seeing escaping it out of a field. And all sorts of things around. Yeah, go ahead, Trevor.
So the general public, when they're looking at that, a lot of the farms up here in the Northeast, they want to know their farmers and know their growers and buy local and the whole movement. That conversation happens with the farmer and the customer or the public. And a lot of people up here advertise that they're using biodegradable mulches or films or things that are better for the soil. And they use this as a value proposition to say, hey, we're growing with the earth in mind and trying to be more environmentally friendly using these products. It's impossible for the consumer or the regular person outside to see the difference in the mulches unless they know the purchase history and what's there. To Shuresh's comment of growers from 10 years ago that he made, people that had trouble with films, those were people that had issues with oxo-degradable films. That was still a poly-based material, not a bio-based material. We have not had complaints from any growers using bio-based products. And if the farmer is advertising they're getting TUV or BPI certified films and showing the products that they're using to the consumer, and everybody's on Instagram or Facebook and all this stuff. Now, when they're laying plastic, they put up their stories and do little verbs and, publications on these stories of what they're using and what they're doing out there. That's how you change the perception to the public and tell you why you're doing something good for the soil.
Thank you, Trevor. Shuresh, is there anything else you would like to add to that?
Just be cognizant of what is on the labeling. This would be applicable to growers who are buying. Again, there is no way for a public to discern if a fragment of mulch is biodegradable, not just by looking at it. So just being cognizant of what standardized methods have the products gone through. Do they pass the standards, or are they just labeled as biodegradable without having to go through all those requirements, which can be the case in the US, interestingly. So yeah, that's what I would add.
Great, thanks. And Rich?
The first thing I want to let you know, we live in California. I mean, those are beautiful stories right there. I love it. But here in California, think about, like I said before, 90% of the berries grown here is coming from California. Imagine how much plastics out there, like just standard mulch. I'm being honest, like throwing it out there. Like, okay, with organic, we don't use no fumigants. So I use rice bran and I, get an anaerobic going. But we have no choice over here. But again, there's a lot of plastic in California. And I think it's just the way it is. And we have to grow with that because we got the weed controls and everything else. So I like I said, over there, like we're talking, I don't know how many acres, And I don't know how many tons of berries come out of California, but it's a lot. But you see the landfill just getting full. And I've said this before from a long time ago, like our landfills are not going to be able to handle any of that mulch anymore coming from the berry fields. You know, before it used to go to landfill, people used to kind of dump it as an erosion control. I still see it to this day. And it was probably dumped 30 years ago. Not by me, but it's been dumped. And so basically we need to tell a better story, especially in California. I mean, it's just kind of the way I see like the direction that we need to go. We need to be more positive as growers, I guess, and be more, do our due diligence. But now that may be me, talking, but maybe somebody else might not think about that way because again, and being in California, just think about the financial disabilities we have growing in California. And we're facing it every day. I mean, come on. I don't know if you guys know this, if you're in other parts of we're paying 40 hours of paid sick leave. They get 40 hours of just free money whenever they want it. And I pay piece rate. If these guys are making $50, they can take that $50 and say, oh, I want my paid sick leave for 8 hours. That's a $400 a day right there for not doing anything. I'm just kind of throwing that out. So being like doing the right thing. But and again, I always tell this Jazmine and everybody else, maybe I'm a little different, but I think you have to incentivize the grower to make it happen because everything's going to come down to financial stability. The shippers are telling, hey, grower, your cost is too high. You need to work on it. Okay.
So that's a question, right? You folks in California talk about your costs and all your stuff being high. We've had 3 presentations on how BDM saves you $80 to $90 an acre. You got to throw the organic thing out because the United States hasn't caught on with the rest of Europe because all this stuff is certified for organic production in Europe. It's cheaper, it's better for the environment, and it's better and cheaper for the grower. And all you have to pull up is drip tape at the end of the year. If you're using a 1.5 mil mulch to grow your organic berries now, you think that solar shrink at 0.9 is better. I'd challenge you to put a 0.9 or a 0.8 bio out there if you could do it, and it would work just as well, if not better. And you could incorporate the soil at the end of the year. I mean, people got to start thinking differently. The Northeast has been doing this. Almost 70% of the whole entire market is why the rest of the world hasn't bought onto this. And we're still looking at this research 20 years later from when it came out in 2003 is silly.
I mean, I agree with the biodegradable mulch on the organic, but they're not letting us do it. The certifiers are not letting us put in any kind of biodegradable mulch in organic and working it in. That's the reason why we don't do it. I don't have a problem doing it, but we can't do it or we can't sell it organically. That's the bottom line for us here in California. And like I said, if you just understand how the whole dynamic in this state works, it's getting tougher and tougher. And I'm not, I'm okay with it because I'm getting a little bit older and I'm kind of ready to do my thing. But it's like, I'm just, but I'm going to do, if I'm going to leave something, this is what I want to leave with. That's why I'm up here and trying to be proactive for the grower here. But I think it's got to be this whole incentive thing for growers to do anything. In the meantime, for me, I went with the soil shrink because I'm using less plastic. That's the bottom line for me.
Great. Thank you for that discussion. And the next question that we have, and Trevor, I think maybe you can kick us off with this one is, from the perspectives, what do you guys perceive as the main benefits of soil biodegradable mulches?
So the major benefits of soil biodegradable mulches for us that are in the Northeast with, one growing season, major benefits is time, fuel, and labor. It saves us money. And a lot of us that are diversified vegetable growers up here, we're doing many, many crops. We're not growing 1 or 2 things. I myself grow almost 200 different types of vegetables. And part of the advantages of biodegradable mulches is its time savings to plant that cover crop and increase our soil health. So biodegradable mulches pair with soil health as a whole system. So we went from, a 7-pass system to prep a field, then lay plastic, transplant, and grow a crop, and then 2 passes to pick it up, and a 5th pass to put the cover crop down. That's 10 passes in a system. With the stone barrier and biodegradable mulches, we're down to 5. We cut our number of passes through a field in half, and we can lay this plastic and put it with certain equipment through a living cover crop. So we can have growing cover crops between our aisleways still live. So without biodegradable mulches, we wouldn't have seen such an improvement in our soil health up here through multiple growers without the use of that tool. It really just saves you that time, and it saves you a ton of money at the end of the year, where a farmer comes down to efficiencies and labor utilization. That's typically the discussion when it's harvest time and you have to decide, hey, do I pick this cash crop with all my labor right now, or do I go pull plastic? No, we save pulling plastic and picking up drip tape and putting all the irrigation away for the cruddy days that you can't harvest crops, or toward the end of the year and it's too late and you're putting cover crops on the end of October, beginning of November, and they don't get a chance to grow and improve your soil health. Biodegradable mulches, we can pick up drip tape in the field in 1/4 of the time compared to using a lifter and plastic winder. So it's a lot more efficient to pick that up, then get the cover crop on, and we're gradually improving our soil health. And none of that would be possible without biodegradable mulches.
Great, thank you for that. And Shuresh?
Nothing more to add there. Trevor, yeah, you did it.
Little bit about. Well, yeah. A little bit about growing berries in California. So basically right now, I'm working ground right now. So we're talking, what is it, August, mid-August right now. Gonna get done. I'm gonna do my first fumigation job, and not this Saturday, but the next Saturday. So we go all the way, my lease goes all the way to November the 30th. You know how long to go? I mean, you're talking 15 months. 15 months. And you know what? If it rains in October, I'm going to pull the plug, because there's no reason to go clean those plants up. But that's kind of what we have to deal with. But our season doesn't start, it's not super short. We got like a 15-month period. Like right now, my organic is already done. It's all bedded up. I got 22 acres of organic using the Soil Shrink 8 mil, 0.8 mil, and it's already ready to go. But now I'm not going to pull that out probably till the end of about the mid-November next year. So I understand what you're saying about that, but we don't have that kind of, we need to make the money throughout the year, or we need to harvest throughout the year, maybe starting late March and go all the way until we can't go no more. But that's our window. And I'm in Northern Cal. I'm in the Watsonville, Salinas area. We have a short window because there's different regions now. Now Santa Maria, they got summer planting, they got everything. They got the both ends of both worlds. They got the back end and the front end. We only got a little blurb of 2 months in the middle of summertime. That's our best market. Maybe 2.5, and that's it. And then you got guys down in Oxnard that come in later on. So there's all these different regions. That's why these big shippers are everywhere now. They're everywhere. So you got to understand, this is California, and this is what we have to deal with. So I'm just trying to find, like I said, man, I would, the Northeast and all that, that's awesome. But this is how we are in California. It's just the nature of the beast of where we're at right now. But again, when you're talking about, yeah, we're not very smart growers, or we're not making the right choices, but we're still producing a lot of berries out in California, and we got to do something about it. Or, I mean, there's going to be an answer, and that's why, Jazmine and her team, Lisa, everybody here, they're going to find the answer in my time.
Great. Well, thank you all for coming with that. We wrapped this section, but when I first started, I said, are we starting with the best talk? And I don't know if you're going to think that this is the best talk or not, and it doesn't matter to me. But what does matter to me is I want you to realize, the nature of this project and of all the talks that you'll be hearing throughout this conference. It's clearly an important topic for our growers and for California. And through projects like this, we're able to bring industry members, work with academia, work with growers. And I'm very appreciative of that. And I'm really appreciative that you are here today listening to this topic and being part of the solution. So thank you with that. And our speakers will be here throughout the conference, so you can reach out to them. And for those that joined us virtually, thank you very much for making time to participate. And you can also reach them out through email. So thank you all very much and have a wonderful evening. See you tomorrow.